All right, in this third set of notes 630, we're looking at limiting reactants. So our stoichiometry calculations we're going to apply from the previous two lessons. There's not any new calculations. This is more of a concept, and we're applying our calculations to this concept. You will need a calculator and a periodic table, so please get those if you do not have those handy. All right, limiting reactants kind of describes what they're talking about. So in a reaction, unless there's only one reactant, obviously that would be your limiting. If you have more than one reactant, you're usually going to have one that's going to be used up before the other one, and that's going to be your limiting reactant. Once your reactant, one of the reactants is used up, your product creation stops. So limiting reactants control how much product you can make. So you can only make as much product as the reactants you have. So once a reactant is used up, no more product is formed. Even if you still have other reactant, you'll just have what's called excess. So limiting reactant is a reactant that limits the amount of product that can be made. It gets used up first, and thus it can make the least amount of product. And then the excess reactant by default would be the other reactant or reactants, and they're the ones that are still left over a little bit. So thus you'll have excess or leftovers of one reactant. So we have to figure out which reactant is limiting, and then we can apply that and figure out how much product we can actually make, because that reactant is going to control how much product we create. So here is an example. Here's a balanced equation for you. We are actually working with moles here, so we only have to do one-step problems. But we are still doing stoichiometry, but we are answering a question. We want to know which reactant is limiting if we have this much. Limiting reactant problems are going to have like two reactants, and they're going to give you two givens. And that's going to be the difference between our last ones. The last ones were just figuring out how to do the calculations. Now we're going to apply that concept. So if we have 6 moles of N2H4 and we have 4.50 moles of H2O2, we want to know which reactant is limiting. Often, I'm going to go ahead and a little bit here. Okay, so sometimes they'll ask you for like how much of a product you're going to make, and so I'm just thinking ahead to make it less work. But what we're gonna do is we can solve this in like several different ways. What I'm going to do is I'm going to pick a product to solve for. So I'm going to solve for N2 both times. So I'm going to use my givens here, and I'm going to do 2 stoich problems. So 6 moles of N2H4. I want to figure out, I'm going to look for N2. So I'm just doing mole-mole ratio because I can answer that question. They're giving me moles and they're not asking me for a certain unit. So 6 moles of N2H4, we have a 1-to-1. So I don't even need to write this out really, but I will. If I have 6 moles of N2H4, that means I'm going to have 6 moles of N2. I'm going to take the other given, 4.5 moles of H2O2, and do the same thing, but I'm going to solve for N, and I'm going to solve for N2 as well. So our ratio is 2 moles of H2O2 to 1 mole of N2. 4.5 divided by 2 is what, 2.25? Now, I solved for the same thing, but what I'm going to say, and this is like, you have to understand what you're doing now. So I took both of these reactants, I solved for the same product. This made less. If this made less, then go back to what you started out with. This is your limiting reactant. And I could have done water as well, but it would have given me the same answer. Like I would have made less water with my H2O2 than my N2H4. So this is my limiting. This now I know by just doing these two calculations, solving for the same things, same product. This is my limiting reactant. Okay, so that I can answer the question. Now there's a second part here because we have an A. So here's our B. Our B says how much of each product in moles is formed. Well, I already solved for one of them. I already solved and I already figured out it was that I'm going to make 2.25 moles of N2 because I solved for that. What I'm going to do is I'm going to take my N2, or I'm sorry, my H2O2, my 4.50 moles of H2O2, and I'm going to solve for water now because I already solved for this one by doing that previous calculation. So 4 moles of, 2 moles of H2O2 and 4 moles of water is on top. So 4.5 divided by 2 really, right? Or I'm sorry, times 2. 4.5 times 2 would give me 9 moles of H2O. Again, I'm writing my stuff out because it's easily confusing. All right, so the answers would be this. I solved this from this previous problem, figured out my limiting reactant was H2O2. So then I took that H2O2 and solved for water, which is my other product. So here are my two answers. All right, this is the same thing. Pause it, see if you can try this on your own. Different equation is balanced. They're giving you moles of each reactant. This time they want grams, but what you can do is you can solve for moles in the beginning and then go to grams once you figured out who the limiting reactant is. If you need more help, just let's do this together. All right, A says identify the limiting reactant if you begin with 0.750 moles of silicon dioxide and 0.500 moles of HF, hydrofluoric acid. So I'm going to solve for just one of them. I'm going to solve for SiF4 because it's a 1-to-1. So I will go ahead and set this up, but SiO2 is 1 mole. SiF4 is what I'm solving for right now. It doesn't tell you to. I'm just pick one. Just pick one. This will give you 0.750 moles of SiF4. Let's do the same thing with HF. I have 4 moles of HF on the bottom, 1 mole of SiF4 on top. So 0.5 divided by 4, should be able to do this in my head. 0.5 divided by 4, yeah, 0.125. Okay, 125 moles of SiF4. Remember, I'm solving for the same thing so I can compare them. This one is less than this one. So go back to here, what you start out with. This is my limiting reactant, HF. So what I'm going to do is, now that I know HF is my limiting reactant, I could take my 0.125 moles of SiF4, which is one of my products, and just convert it to grams because they want grams this time. So what is silicon weighs 28.09 and fluorine weighs 19. So what is it? 28.09 plus 4 times 19. All right, so 104.09. That was okay. So if I just multiplied 0.125 I get 13.0, all right, grams of SiF4. Okay, this is one of my answers, so I'm going to box it. All right, I need to solve for water still. Now remember, I figured out HF was my my limiting reactant. So I'm going to start with HF. And this time I'm going to grams of water. So I'll do my molar mass. This is a mole to mole. Okay, that will cancel out. And then 1 mole of water weighs 18.02 grams of water. So 0.5 times 2 times 18.02 divided by 4. All right, clear everything. So 0.5 times 2, no. Oops. Okay. Times 18.02 divided by 4 is 4.51 grams of water. So in theory, this is how much product I should produce if I was given this much of each reactant. Now, you could figure out how much of excess you have of the silicon dioxide. We're not right now, but you would just, sometimes you can actually see it, like just unreacted sitting on the bottom of a container. But that's going to be your excess reactant. So your HF is your limiting, and then by default, if we want to term who's in excess, it would be silicon dioxide.